Welcome to one more videos of my lecture on the physics subject. Today I have chosen that is the banking of the curves. Well, the meaning of banking of the curves is that you must have seen that whenever a curve is there on the road, like in the hilly places or even in the plain areas, when the road is taking a curve, then there is a slight bit of inclination in the road, and this inclination of the road is given for the purpose of the vehicle not skidding out to the outer side and toppling over. This is a process to hold the vehicle in place. Imagine this to be the inclination of the road. So the road has taken a curve like this, and supposing this is a vehicle moving like this, and when the vehicle is at this place, what happens is that it is banking is given to ensure that the vehicle doesn't go off the road. If it was straight this way, when the vehicle would be turning like this, then the every possibility of there is that with the vehicle with so much of mass and with so much of velocity, it will always have a tendency to fall off like this. So to ensure that or to protect the vehicles from falling off, the road is given a slight tilt or the angle like this, so that the vehicle doesn't fall and it turns smoothly like this. What are the aspects to be taken care of, and what are the points of the highlights to which the attention is to be given, and what amount of the tilt of the angle is made? What is the maximum speed that has to be maintained in the road, beyond which if the speed goes beyond that, then there might be every chance of the vehicle falling otherwise, because the angle of tilt is made for certain speed only, and beyond that speed it won't hold the vehicle, it will rather fall off the road. So let's see what are the relationships between the angle of the tilt and the velocity of the vehicle, and also the radius of curvature, the radius by which the curve has been made, so the radius of curvature. So that is also a point to be noted. So let's see by the formulas in which the calculation of the angle of tilt is to be made. The centripetal force upon turning, it will tend to throw up the vehicle like this. So the centrifugal force developed will also be taken into consideration. When there is a curve, it is a curve like this. So say at a point like this here, stand here and look at this. Look in this direction, A. So what you will find is that if you are standing here and looking at this direction, looking at this plane, so what you will find is that the road appears to be inclined like this. This is the plane and this is the inclination. Let's say the angle of inclination is theta. So what are the things that are to be this is the vehicle. So take this to be the center of gravity of the vehicle. That means the whole force acts on this, and the weight also is acting on this to this point, and the forces developed will be the what are the forces included? That is the weight. Forces equal to weight and the centrifugal force. The centrifugal force will be acting in this direction. This is the CF. Let's say CF for the centrifugal force. Let's say CF for the centrifugal force. Okay? And what else? This is the weight. W. W is mg, equal to mg, or m is the mass of the vehicle and g is the gravitational force. So as you have said, the inclination of the road, it will prevent the vehicle from skidding. To cancel out the skidding force that has to be applied. So what is it? This, it is said that if an angle of inclination is made, a component of this weight, it acts in this direction. Along the road, it acts in this direction, which cancels the component of this centrifugal force in this direction. So the forces acting on the block or the vehicle are the F, the centrifugal force and the weight. The centrifugal force and the weight. This is mg. So to avoid skidding, the component of F in this direction, because F will be having two components, that is, one will be perpendicular to the surface and the other will be along the surface. This. So what is the value of this? If this is theta here, this will be this, along this it will be F cos theta. It will be F cos theta. And the component mg along this will be what? So let us make this hypotenuse as the mg, and we will find out the component of it. This will be theta. This is theta. So if this is theta here, This will be the component of mg. This will be how much? Mg sin theta. This mg sin theta here. So these two forces have to be equal to avoid the skidding of the vehicle. That means what? The mg sin theta will be equal to f cos theta. F means equal to mv square by r cos theta. Okay. This will be mg sin theta will be equal to mv square by r cos theta. So mg sin theta will be equal to f cos theta. That means mv square by r cos theta. And so if we bring this cos theta to the left hand side, we get sin theta upon cos theta is equal to mv square by r into 1 by mg. That means equal to v square upon rg. V square upon rg. And what is sin theta upon cos theta? That is tan theta. So it will be equal to, that means tan theta finally we get a formula, that is tan theta is equal to v square upon rg. The variables are what? Variables are, if for a given inclination, variables are what? V and R. And if the radius of curvature is fixed, if it is having a certain radius of curvature R, this is having a certain radius of curvature, R will be fixed and the theta will be fixed. So from that we can find out the velocity. So in this way the banking of the curve is met.